Hello there, ladies and gents. Welcome to video number 100, and to mark this momentous occasion, I have dyed my hair pink. Now, this one is on graph transformations. Keywords are translate, reflect, and the key notation in this one is y equals f of x. When we translate something, we're moving it from one place to another. Reflecting is flipping the image, and in this instance, it will be flipping it in either the x-axis or the y-axis. And y equals f of x means y equals the function of x. Okay, the function of x is just something that's happening to x, and we don't get given what that equation is. We just use y equals f of x most of the time. Sometimes you do get the equation. Anyway, basically the method states you just need to learn the following things. All right. Now, if we add something to the function of x after this function of x, if we add something, that means that it's going to move up by that something. Okay, so if it's a, then we're going to move up by a units. So if that number is 8, we're going to move up by 8 units. Okay, if it's a negative number on the outside, that means we're going to move down by that many units. Okay, if we've got a number on the inside of the bracket next to the x, if it's positive, that means we're going to go left by that many units. And if it's negative, we're going to go right by that many units. All right, learning this will help you translate the graphs easily. Okay, learning these two will help you reflect the graphs easily. So if you've got a negative function of x, that means you're going to reflect in the x-axis. And if you've got the function of x and the negative is inside the bracket next to the x, then that is going to be a reflection in the y-axis. Okay, so this makes things nice and simple. Now let's have a look at that in action in question number 1. So the graph of y equals the function of x is shown. Write the coordinates of the new position P when the graph is transformed to y equals function of x plus 2. So function of x is this is y equals f of x. Okay, we don't know what the actual equation of the graph is, and it doesn't matter because we've got the minimum point here of the graph. It is at 3, 2. Now that point, if I just mark on there 3 and 2 for you, that point is going to be translated, right, as would the rest of the graph be. And we'd be able to state what the point of that is if it's gone 2 units up, right? If it's gone 2 units up, the coordinate value will be 3 still, because it's still on 3 on the x-axis. And it'll be up to 4 on the y-axis. So that one is 3, 4. Okay, pick up a mark for each of these, which is pretty simple, but it is grade 8 stuff. We've got minus 4 on the outside of the function of x this time, and that's just going to mean that it's going to move down by 4 units. So it moves down by 4 is going to make it minus 2. So x-axis is still the same, but y-axis coordinate isn't minus 2. And then c, we've got no bracket around c there, just add that in. We've got y equals the function of x plus 5. That means we're going to be moving left by 5 units, okay? Which means the y-axis is the same this time, so that's 2, right? And we're just going to move 5 units to the left. Okay, so that's going to be minus 2 from where we were. All right, I hope all that makes sense. Just employing the first 3 of these rules that we can learn. Now, number 2, the graph of y equals the function of x is shown. Write the coordinates of the new position P when the graph is transformed to. Now, this one with the 4th one, so we're going to do a movement to the right by 12 units. So there's our function of x, this horrible looking graph. The maximum point is here, minus 1, 8.5. So that's just going to move 12 units to the right, which means adding 12 onto minus 1, which would gets you to 11. All right, so 11, 8.5 is the answer there. Now, this next one, y equals minus f of x. It's a different one, isn't it? So we've got the reflection in the x-axis. So if we reflect in the x-axis, what's going to happen to that coordinate is it's going to be exactly the same distance away, but in the negative. All right, and it's still going to have the same x-axis coordinate. So minus 1, and then if that's at 8.5, then we'd be in minus 8.5 on the other side. Okay. And then this one is a reflection in the y-axis. So this point is reflected over here in the y-axis, and that would be difference of 1 here, and this is a difference of 1 here. So that would be 1, and then we'd still be at 8.5. Okay, now I hope all that makes sense. All right. you might get asked to sketch them, and that's what we're going to have to do in the third question as well. And we've got a combination to go along with question B as well. So the graph of y equals the function of x is shown again. It's just y equals f of x. You can see this one's a quadratic, but again, we don't know what the equation of it is. We've got to sketch the graphs this time. So this one, y equals the function of x minus 4. Well, that just means that the graph moves down by 4 units. You might want to get some tracing paper. Put your hand up, ask for some tracing paper, sketch the graph on it, move it down 4 units, right? And then draw it on again. It doesn't have to look absolutely perfect. It's got to be the same shape graph. It's got to have the right coordinate point as well. So we're going to move down by 4. All right, and that difference there is 2 on this kind of sketch that they've done. So let's have that same difference there. All right, and we'll say that's our minimum point there. And I'm just going to draw the same sort of sketch. It doesn't disappear. All right, and there, I don't know why the pen's just lagging a little bit irritating. A little bit messy, but there we go. So we got the same sort of sketch there, and our minimum point is that point that I'm just making highlighted, and I'll just label that up here. Okay, and again, it's just scratchy, the pen, for some reason. I don't know why. Let's have a little tightening up of it, see if it can work a bit better. Right, so that point there would be 5, and it would be minus 2, because we moved down by 4 units from where it was. Now this one is a combination of two things that's going on, because we've got negative f of x and then we're adding 8. Alright, so negative f of x is going to be a reflection in the x-axis, so that would be our minimum point there. Alright, but we're going to move that up by 8 as well. So moving up by 8, we're going to go up there by 4 and then add 4 onto that, so that's going to be about there. Okay, and then that's going to be the same shape graph but upside down. So that's that one, right? And you might want to label those graphs actually on your sketch that you do. Okay, which one's which? So f of x minus 4 is this one, and then this one is minus f of x plus 8. Okay, and then we know the that difference was 2, that difference was 2, that difference there is 4. We've gone up by 8. And that means that we are at 5, 6. And that's the number, or the coordinate numbers that we need to pop in there. Okay, and the pen is working a little bit better now. We've done the vertex in each instance, and that's the end of that video. All right, you might get a little bit more complicated than that. You might have to do a combination of these things. You might get the equation. You might have to figure out what's happened to the equation, but that's the principle of it. Okay, learn those things that for some reason I've got a little scratchy red pen over. Learn these rules, all right, and this topic becomes a nice simple grade 8 topic. All right, I hope you enjoyed that one. Thanks for watching. Please practice using the LinkedIn resources. Like the videos if you like the videos. Subscribe to the channel if you want to subscribe to the channel. Do what you want, but just get better at maths. Hope you like my pink hair. Thanks for watching. Bye bye.